Hello, good day viewers. Here is another nice rational inequality. 1 divided by 1 plus x plus 2 divided by 1 minus x squared less than or equal to 2 divided by x minus 1. Let us talk about domain first. From this one, you know our denominator cannot be equal to 0, hence x cannot be negative 1 here. And x cannot be positive 1 here. Remember that this is difference of two squares, a combination of this and this. And hence we can conclude that x cannot be plus or minus 1. So x cannot be plus or minus 1. Now let us bring this term to the left hand side. To the left hand side we already have 1 divided by 1 plus x, but I can write it as x plus 1 all the same. And this can be written as what? Negative x squared minus 1. They are all the same if you factor out negative 1. So we can write it as minus 2 divided by x squared minus 1. As this crosses over, it becomes negative 2 divided by x minus 1. Nothing to the right hand side, so we have less than or equal to 0. Remember that this is what? X minus 1 multiplied by x plus 1. This is difference of two squares. So we can make every single denominator to become x squared minus 1. We can do that by multiplying this by x minus 1. And we can do that here by multiplying x minus 1 by x plus 1. So let's do that. The first one, by multiplying the bottom by x minus 1, you have to multiply the top by the same value. So we have x minus 1 to the top. To the bottom we have x squared minus 1. The minus 2 divided by x squared minus 1. The minus, if you multiply this by x plus 1, it becomes x squared minus 1, right? X squared minus 1. But remember to multiply the top by the same value, which is x plus 1. So we have 2 times x plus 1 less than or equal to 0. Let's further break it down. Since we have common denominators, we can add the numerators together. The numerators are x minus 1, then we have minus 2, then we have minus, we can expand this, right? Using minus 2. Minus 2 times x is minus 2x. Minus 2 times 1 is minus 2. The whole of this divided by x squared minus 1. Still less than or equal to 0. Let us collect the like terms. We have x's x minus 2x, that is negative x, the minus 1 minus 2 is minus 3, the minus 3 minus 2 is minus 5, so we have minus 5 here, divided by x squared minus 1, less than or equal to 0. Remember that the denominator cannot be equal to 0. So from here we can assume that the whole of this is just an equation, negative x minus 5 divided by x squared minus 1 to be equal to 0, assuming it is an equation. It implies that negative x minus 5 will be 0 because the denominator cannot be 0, right? So if the whole of the left hand side is equal to 0, it's only if the numerator is 0, right? So you take negative 5 to the other side, it becomes positive 5. So negative x equal to positive 5, and you divide both sides by negative, you have x to be negative 5. So we have 3 critical points. Remember, our domain is plus or minus 1, and we have this value of negative 5. We are going to plug them on a number line. So if we have a number line here, the 3 values, we have negative 5 here, we have negative 1 here, and we have positive 1 here. We are going to test them in the main inequality. But I'm going to use the simplified version, which is this one. So if we consider negative 5, what will be the value here? If x is negative 5, multiplied by this negative, it becomes positive 5. 5 minus 5 is 0. So we have 0 to the top. You know, the bottom will be a number, but 0 divided by whatever will be 0, and 0 is indeed less than 0 or equal to 0. So therefore, -5 is a solution. But remember that -1 and +1 cannot satisfy, because the moment you plug them into the inequality, the bottom will be 0, which we don't want. So you have an open cycle here and here, indicating that they cannot satisfy the inequality. Next, we need to test values to the left-hand side of -5, in between -5 and -1, in between -1 and 1, and to the right-hand side of +1. So let's choose -6 here. Let's choose -2 here. And let's choose 0 here. Let's choose 2 here. So these 4 values are going to be tested. Let's start with -6. If you plug in -6 here, x will be -6 times this negative, it will be +6, and that +6 minus 5 is 1 to the top. To the bottom, we have this, which is -6 squared, which is 36, and 36 minus 1 is what? 35. And 1 divided by 35 is greater than 0, so it cannot satisfy, because this is less than or equal to 0, but this is greater than 0. So all values to the left-hand side of -5 will not satisfy this inequality after -infinity. So we cross them like this. Then -2, what happened? If x is -2 times negative, we have +2. +2 minus 5 is what? -3. -2 squared is +4, and 4 minus 1 is 3. So this is what? -1. And -1 is indeed less than 0. So all values here will satisfy, in between -5 way down to -1. Then we test 0. If x is 0, 0 times whatever here will be 0, and 0 minus 5 is -5. 0 squared is 0, minus 1 is -1, so this is 5. And 5 is not less than 0, so it will not satisfy. No value here will satisfy the inequality. Then we test 2. We have 2 times negative is -2, and -2 -5 is -7. To the bottom, we have 2 squared is 4, and 4 minus 1 is 3. This value is indeed less than 0, so it will satisfy the inequality. So you can see our solutions are between -5 down to -1, and from 1 to infinity, right? So we say that x value belongs to the set of values from -5. We use a square bracket to indicate that -5 is a solution, way down to -1 excluding -1, so we use parentheses, union from 1 way down to +infinity, and hence this is said to be the solution to this problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.